So we can write this as this will be coming as our 3 mass cancel with mass, and we get this as our 3 times omega plus omega prime is equal to, and 1 second, and in U there is one term that is missing, is our L. So here we are left with our ML, and this will be coming as our L square, and this will also have L square. L square cancel with L square. Now it is correct, and this will be equal to our twice omega minus omega prime. So from here we get that our omega prime is equal to minus omega upon 5. So this is our final angular speed of our stick, and negative means the direction will be opposite. Okay. So this was our first question. Second question, and it states that a uniform stick of mass m slides without rotating on a smooth frictionless table and collides elastically at one of its ends with the ball of m at rest. The mass distribution of the stick is such that its moment of inertia about its center is given as I is equal to a ml square, where a is a constant. Determine the value of a for which, after collision, the ball moves with the same speed as the center of mass of the stick. So basically, this is a same question with the stick and a ball, but in this case, the constraint is little bit different. We have to find out that the ball should be moving with the same speed as the center of mass, and based on this, we have to find out the value of a. Okay, this is. So once again, the basic figure is going to remain same. Length is L of the stick, and its mass is given as m, and we have a ball which is having a mass of m, and they collide elastically, and the moment about the center of mass, so let us suppose this is the center of mass, and its moment of inertia is I, and it is given as a ml square. Okay, and we have to find out value of a under the condition that our ball and the center of mass speed is same. So let us assume that after collision, center of mass moves with the velocity let us suppose that is capital V, and stick is rotating, so it is rotating in this direction with angular speed of omega. Okay. And this is, mind it, after collision. Okay, and stick rotates with angular velocity that is our omega. And we also can write that ball moves with the velocity u. Ball moves with velocity that is our u. Later on we can just substitute our equation. Okay. And first of all, we are going to use the momentum conservation. Okay. And in this case, one second. Okay. So let us consider that our momentum conservation and momentum conservation, and we have our initial momentum, that is m v naught is equal to mv plus mu. Therefore, from here we can write that our v naught is equal to v plus u. Here v naught is our initial velocity of our center of mass. So we can just write that v naught is initial velocity of center of mass. Okay. And we can write the angular momentum equation also. So we can say initially there is no rotation, so we can say that initial angular momentum is equal to 0. Initial no rotation, therefore initial angular momentum of stick is equal to 0. And after collision we have assumed that its angular velocity is equal to omega, therefore its angular momentum will be equal to I times omega. And we can just write the equation that our 0 will be equal to our I omega plus L by 2 times mu. And from here we are going to get that our omega will be equal to minus mul divided by 2. And moment of inertia, that is I, is given to us. So we can write this is minus mul, and here it is 2I times 2, and this is A, and we have this is ml square. And mass cancel with mass, square goes away. So we get this as omega is equal to minus of u divided by 2al. Next, we can use the conservation of our kinetic energy also. So we can say that kinetic energy conservation and initial will be equal to final kinetic energy. So initial we have only 2m v naught square is equal to the kinetic energy associated with our center of mass plus our rotational kinetic energy and the kinetic energy that is associated with our ball, mu square. And we already know the value of u, and okay, so we can just rewrite the equation because we can substitute here the value of omega. So we can write this over half m v naught square is equal to half m v square plus half m u square plus half I, and our omega is our minus of u al minus of u 2al whole square. Therefore, and here, okay, let me solve it first, then we can substitute the values. So we can just cancel out this half throughout, and we get this as m v naught square is equal to mv square plus m u square, and this comes over I, and this moment of inertia is given to us as a ml square, and this will be coming as a u square plus 4a square and l square. And once again we can cancel out m throughout, l square cancel out with l square, and a square go by a. So we are left with only that our v naught square is equal to a v square plus, and we have our u square plus, and in the last term we will left with the u square divided by 4 times a, and we can combine these two terms. This will be giving us our v square plus u square 1 plus 1 upon 4 times a. And we already know our v naught, we just calculated. Let us pose this as equation number 1. So using equation 1, from equation 1, which is our v naught is equal to v plus u, and we substitute in place of this v naught, this will be giving us v plus u whole square is equal to our v square plus u square 1 plus 1 upon 4 times a and whole square. We can open our left side, we get this as our v square plus u square plus 2vu is equal to this, one second, this is not the square, and so we can write this as our u square plus u square upon 4 times a, and our v square u square cancels out. Therefore we get this as 2vu is equal to u square upon 4 times a, and we can rewrite it as, we can take u as common, and this will be coming as twice v minus u upon 4 times a is equal to 0. And from here obviously u cannot be equal to 0, therefore we can write this as twice v minus u 4 times a is equal to 0, or from here we can say that v is equal to u upon 8 times a. Okay, so this is our velocity of our center of mass. But we are given a condition in the question that the ball moves with the same speed as the center of mass of the stick. It means V should be equal to U. That's a given condition for us. Therefore, we can write that as per given condition, we have that our V is equal to U. Center of mass speed should be equal to velocity of the ball. And obviously, we can substitute in this equation and we get this as U is equal to U upon 8A. Or we can say our 8A is equal to 1, or we can say A is equal to 1 by 8, which we were supposed to find out. Okay, so we were supposed to find out the value of our A, and A was our with respect to the moment of inertia. And the constraint on this value of A was that the ball moves with the same speed as the center of mass of the stick. So this was the constraint on our for calculating the value of A, which we used in the final part of our equation or solution. In the final part, we just wrote that as per a given condition, V should be equal to A. We substituted here, and which gives us that the value of A should be equal to 1 by 8. Okay, so these were the two questions which we solved today. Okay. And so this completes the two questions for the today. Next, we are also going to continue with the two more questions. Thank you.